Okay, so happy Monday, everyone. Today we are going to start our probability and statistics unit, which is about um, looking at how likely something is that it happens, or that's probability is trying to figure out how likely is it that something is going to happen. And statistics is about kind of analyzing data and figuring out what if there are any patterns in how a group of people or a group of things are acting or working or thinking or something like that. Um, Super different from what we've done so far this year. So if you kind of hated everything we've done so far this year, maybe this will be the thing that you'll like. Yeah, let's go. Let's do it. So our first big idea, this is kind of the definition of the word probability. The probability of something happening is how likely we think it is that it will happen. And so we can do this mathematically and we can do this experimentally, and we'll kind of try to experiment with the differences between those two things later this week and probably next week too. This will help us make some predictions about events and whether we think things will happen or whether we think things will not happen. Um, the probability stuff is going to happen starting sort of mostly next week. In order for us to know a probability, we need to know, I guess, as sort of a vocabulary word that I don't really use a lot, but it's important that we have it. The word is sample space. And sample space just means what are all of the possibilities. And so if we can figure out all the possibilities, and we can figure out, then we can start to figure out our probabilities. So we're going to start kind of looking at sample space. Well, really what I want to look at is how many possible options there are for outcomes of events. So we're going to do that today, and then we'll get into the probability stuff later. We are in learning target 11A today. 11A is about tree diagrams and the fundamental counting principle. And then we'll get into some of this other stuff later. Okay, here's sort of what I guess is kind of a silly example. And I'm going to draw a little diagram here. I'm going to draw what's called a tree diagram. And that's a hint that we're going to make something that looks kind of like a tree, and it's going to be a little bit of a stretch, but it'll be all right. Okay, so here's Alex. Alex can choose 3 pairs of pants. Maybe he has some blue pants. Maybe he has some gray pants. And maybe he has some, I don't know, red pants. Okay, so those are his 3 pants options. But for each of those pants options, he could choose 8 different shirts. And so we could say shirt 1, 2, 3, 4, 5, 6, 7, 8 shirts. That would be his 8 different options for his blue pants. But for his gray pants, he could wear those same 8 shirts, 3, 4, 5, 6, 7, and 8 will do. And then for the red pants, we could do the same thing. 1, 2, 3, 4, 5, 6, 7, and 8. So how many total possible outfits does Alex have to wear? Well, he's got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 possible outfits to wear. So we could say 24 possible outfits. This is called a tree diagram because if you kind of see this, I don't know, it's sort of vaguely tree shaped. You know, there's my tree stump. Okay, so this is called the tree diagram. What it shows is all of the possible outcomes of a set of things that you could choose. Thinking about all of the possible outcomes, maybe when you have 2 or 3 or 4 things to choose, it's really helpful for us to have these tree diagrams. And I'm going to show you another example of this. Here we go. So, by the way, the word fair just means each outcome is equally likely. Like, you know how when you flip a coin, it's like 50% chance that you're going to get heads and 50% chance you're going to get tails. Same thing with a die. If you roll a die, it should be 1/6 of a chance to get a 1, 1/6 to get a 2, a 3, a 4, and a 5, and a 6. So that's what the word fair means. Fair just means equally likely. How many outcomes could we have if we flip a coin and then roll a die? So let's see. If we flip a coin, we could either get heads or we could get tails. If we roll a die, we could either get a 1, a 2, a 3, a 4, a 5, or a 6. And here we could get the same 4, 5, and 6. We could get those same 6 outcomes. So total, we could get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ways. All right, so again, we can draw that tree diagram to kind of show all of the work to show how many different possibilities there are. Now, this is a lot of words for a very simple idea, and we saw it on the last 2 slides. Remember when we said we had 8 pairs of pants and 3 shirts? Nope, just kidding, it was the other way around. Sorry. We had 8 shirts and 3 pairs of pants, and we got 24 outcomes. That was 8 times 3. And we did the heads. We had, we had the coin, which was 2, and the die, which was 6, and 2 times 6 is 12 ways. So the fundamental counting principle says that if you can do something this many ways and this one this many ways, you can take the numbers of ways and multiply them, and that tells you the total number of ways that you can get your answer out. Okay, now I'm calling this simple because that's sort of the way that we describe it in math, but that doesn't mean that it's easy. Simple just means that there's not that much stuff going on, but the calculation can still be a little bit tricky. So in Minnesota, let's look at the license plates that we could get out. So I know about Minnesota license plates that we have number, 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 and then letter, letter, letter. And so my question to you is, how many different ways can we select a license plate? Okay, so how many options are there for the first digit? Well, the first digit could be 0, 1, 2, 3, 4. It could be 5, it could be 6, it could be 7, 8, or 9. How many ways are there for this digit? Well, this digit has 10 ways. And so this would be 10 ways right here. We have the same set of choices for this one because you could, if you got a 0 here, this could also be a 0 if you had a certain license plate. There's no reason that we can't repeat those. So we can have that. And then that means that this one would also be 10 ways here. The next set is the letters. And how many letters are there? Well, there are 26 letters. Oh, that's a bad color for this process. So let's write 26 in black. Okay, 26 ways here. We could have 26 here, and we could have 26 here. Okay, so all together, how many possible ways could we get a license plate out? Well, we could have 10 times 10 times 10 times 26 times 26 times 26. This is the fundamental counting principle. This is saying, this is the, I'm going to write FCP here for fundamental counting principle. This says if we have 10 ways to do this, and then 10 ways to do this, and then 10 ways to do this, and 26 ways to do this, and 26 ways to do this, and 26 ways to do this, then we can take all those possibilities and multiply them to get the total number of possible outcomes. I'm going to use my calculator for this because I'm going to get a big number, 26 times 26 times 26 times 10 times 10 times 10. And I get, whoa, okay, 1757600. So I have 17,576,000 ways to get a possible license plate in Minnesota. Okay, we're working towards our way of getting this answer. But before we start that, let's do some smaller problems. And so what this is asking is, okay, let's say we have some people running a race. We want to know how many different ways those people can finish the race. So who gets first, second, and third is really the most important, but we want to kind of count all of the other ways to get the fourth, fifth, sixth, seventh, and eighth places also. All right, so let's start with the smaller problem. I guess there should be an S here, huh? Let's start with this smaller problem. Let's start with 3 people. If we think about this, how many possible ways can we get the first person to finish? Well, either person A or B or C could finish the first spot. To get second, let's say that if person A wins first place, then we could only choose person B or person C for second. But let's say person C wins second place. So now how many ways could we choose the third person? Well, just B. So that would just be one way. So we have this 3 times 2 times 1. The fundamental counting principle says we can take those 3 different ways and multiply them. So that would give us 6 ways. All right, let's look at 4. In 4, we would have A, B, and C, and D people. We have those 4 people for first place. Let's say that person C wins first place this time. So then if they win first place, we could only choose A or B or D for second place. So that would be 3 ways. So now let's say that person D wins second place. Well, now we only have A and B for third place. And so let's say then that person A wins third place. Well, then that makes it have to be that person B wins fourth place. I guess person B is just not a very fast runner. Okay, so how many ways do we have to do this? Well, we can have 4 times 3 times 2 times 1 ways. 4 times 3 times 2 times 1 is 24 ways. So now let's go back up to the 8-person race, because I'm noticing a little pattern. I'm noticing this 3 times 2 times 1. I'm noticing 4 times 3 times 2 times 1. I'm thinking that this is probably going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. When I do that multiplication in my calculator, I get 40,320 ways. Here's a little formula for you. If you're trying to put n things in order, n is just a number. N things in order. So like we had that 8-person race, you could think about this as maybe like people in line to get tickets for a concert or something like that. The number of ways that we could put these people in order or these things in order is n factorial. We say n factorial. Factorial is the exclamation point, and that means that you're taking the number. So we had 8 factorial the last time. That was 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We go all the way down to 1, and then we stop at 1. We don't multiply by 0, because if we multiplied by 0, then there'd be 0 ways to do something. And we know that that's not true. Okay. 8 factorial is, we found out that it was 40,320. We can see that these factorial numbers get really big really, really fast because 8 isn't even that big of a number and there's already 40,000 ways. Just for your reference, something that's a little bit weird, but 0 factorial is 1. If you don't have that, then it makes the math really weird, and I'm not going to spend a lot of time explaining that, but 0 factorial is 1. Okay, it is a good idea, probably, to try doing some of these in your calculator. The set of things you're going to do in your calculator is you're going to type the number, so we're going to type 0, and then we're going to click the button that says Math, then you're going to scroll over 3 times, and then you're going to scroll down 3 times, and then you're going to hit Enter. So that's going to take us Math to the probability tab, and then you're going to scroll down to the thing that says factorial. Okay, all right, 0 factorial is 1, we know that. 1 factorial is 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. And then 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. It might be helpful to memorize a couple of these, but I am not going to force you to do that. Just know that you can always be using your calculator for this kind of stuff. All right. The practice for today is mostly about the tree diagrams and the fundamental counting principle. There's a little bit less of this factorial stuff. So get that done, check your work against my answer key, and then make sure you get the mastery check done.